السلام عليكم ورحمة الله وبركاته. أنا الدكتورة آية نصار من قسم الفيزياء الحيوية كلية العلوم جامعة القاهرة. يسعدني أن أشارك معكم اليوم في ورشة العمل ونتكلم عن Data Strategy, Visualization and Storytelling. To start with, we know that information technology, it keeps updating from probably 1 month to another, not just waiting for each year. Data analytics, they are the driving force behind the decision making, especially when we talk about drug delivery and drug design. The outcome of this lecture is to make you understand what are the different framework for data strategy, how to integrate the different foundational concepts, what are the effective data visualization tools that you can utilize in your research or at your work, and how to draft a data-driven storytelling. The presentation today, it will go through different elements. We will highlight the importance of data. What are the different types of data, different sources? How would you analyze your data? How can you visualize them? And what can you tell and infer about the insights from your results? And what is the takeaway and recommendation? We know that data, big data, they are playing a major role nowadays, and there are a lot of importance level of data decision and communication. Especially in the field of biophysics, we know that complex data, they are related to molecular structure, interaction, and dynamic processes. And it's very important to visualize the context of your data and how they are related to the manner of what is going and how you want to infer the results. Also, data, it play a major role in discovering patterns and differences. For example, if you are analyzing a correlation between a risk, effect, and a disease like cancer, how would you explain this? How would you relate it? What are the patterns that you are observing in different population, in different geographic areas? And what are the different hypotheses and discoveries that you are working on? The storytelling for your context, it provides a framework for how you want to put the data and how this will help you as a researcher and will help other people to repeat your work. As well, it tells different questions and how you can answer those questions, starting from collecting the data, analyzing the data, and providing the insight, and how can you conduct your research to different audience from different disciplines. As well, data play role in decision making. We see a lot of stakeholders, especially in the industry field, like in pharmacology, how they can take the visualization of data and tell a story about what they can do and infer about decisions, probably for designing a drug or probably for making different solutions. So researchers, they can use the visualization of the data that you have collected and analyzed to show and highlight the significant findings of recommendation for future directions. As well for the public. So the public can be engaged, and this is how you do when you present your data in dashboard, especially the dashboards for like the public health department or for the Ministry of Health or for the like the medicine for any of those pharmaceutical companies. So you are engaging the public to be informed. As well, data is a major part in your publication, especially when you do peer review articles and you publish them. Just putting your numbers is not indication of anything. You need to represent it and see how this can be interpreted and how this visualization can tell the story. To talk about data, we need to understand what are the different types of data. And this takes us to see what are the data and where you can find data. Data, they can be stored in house. That could be your local device or the place where you work, and it can be available in the cloud, like online for those data, open data devices. You can think about data warehouse as it's the library, and this is the traditional way of looking at it. So the library is your server where you keep the data. And when you reach to the book, this is the database that you are reaching for. The page that you are browsing are the different tables that you are looking for. So when you store your data at different data frames or at different tables, these are the pages that you are browsing, and this is what you want to retrieve when you want to analyze the data. There are different data types, especially for research. There are data for biological analysis, like biological data, and that can be utilized for like drug databases and enzymes. There are data that concerns genes and genomics, and this is like when you look for gene databases and sequences analysis. There are computational models and algorithm data. This is what you use for protein structure, prediction, and for the docking algorithm. There are experimental data, and the experimental data is usually what you work in medical field, like the data for diagnosis, X-ray, crystallography, NMR, and spectroscopic data. There are data that you can use for prediction and simulation, and this is what you can use in Monte Carlo simulation, as well as quantum mechanics calculations. And there are bioinformatics data, which is the big data that we deal with right now. And this is how you can see the data are stored in protein data bank, UniProt, and the gene bank. So there are different data sources that you can access, and it's free for the public. You can retrieve those data. They are published already and they are reliable. For example, the data that are stored on the National Center for Biotechnology and Information, what we call the NCPI. There are the European Bioinformatics Institute. This is the API, and the Protein Data Bank, where you can get the structure of the protein. There's also other websites where you can access biological data like the UniProt, Gene Bank, and the KIG Genome Encyclopedia. And this is where you can get the framework and the network of the biological pathways. There are different open data sources. If you would like to practice, you can download some of those data. Um, However, not everything is for free. However, those data that has been published and has been analyzed might be available to you to do some secondary data analysis. And that could be for any open data frameworks, like how you get on the GitHubs, and scientific research publication, just like Nature Scientific Data. There are Center for Open Science. So you can browse the internet and you can use some keywords like open data frameworks, and then you can practice on some of those data. Let's take a moment and just recap about what we are talking about data. So, when integrating bioinformatics data from multiple sources, which means that you are retrieving data from different data sources. So, the first step that you should consider is apply a 3D visualization, choose the color scheme for the graph, clean and normalize the dataset, or write the conclusion. So the correct answer is clean and normalize the dataset. So you have different data sources and probably they don't have the same variables. So the first thing you want to do is clean the data, sort them, and source them in the way that there should be at least one common variable that can connect the different data sources. Let's take another question. Which chart type would be best to visualize protein-protein interaction network? So you accessed the protein structure and you would like to look at interaction between two different proteins. So the best interaction that can show your data would be a scatter plot, pie chart, the network graph, or a histogram. So the correct answer would be the network graph because you want to show the connection and how the proteins they are interacting and which site they are interacting at. There are different data tools that can make you easy manage the data that you have. The common tools what are commonly used recently are the R Studio, the Python SQL. Those are the common data tools that where you can manage the data that has been stored, you can retrieve them, you can write a code, and then you can merge the table. You can come up with some data framework so you can analyze different data sources. Among those data tools, there are tools for the management. Many of those tools, they allow you to interact and extract the data visually so you can see what you are extracting, what you are getting from each table. The most common one is the Microsoft SQL Server, and this is a management system where you can sort the views in the tables and you can retrieve what you need. And you don't need to get everything in the table. There are some graphical user interface like the GUIs, and those they provide some graphical interference that will allow you to have a query and retrieve the data without having to write a code. Those are point and click functions so you can design your queries. There are also the traditional programming languages. In the old time, we used to write all the scripts. Nowadays, you have some libraries that are built in the software, like R Studio and Python. You can download the library and it's already set for you, so you can apply those libraries. You only need to set the variables that you are analyzing. There are also APIs, and the APIs, those allow you to access the different programs. Usually, they are useful to retrieve the data within an application. There are also different extract, transform, and load tools, and those are powerful queries. So you can extract the data from different data sources, and then you can load them into the database. And if you are browsing a Google, for example, Google page, and you found a table that you like, instead of copying and pasting the table, especially that the format will be different, you can do something called web scraping. And web scraping, it will allow you to extract the data from that page and save it at your local device. There are different data tools that you can utilize. They are wide variety of them. There are also different formats like the CSV format, the Excel, the JSON, where you can just retrieve those data, download them in your device, and then change the format. So you can extract it as an Excel sheet, and then you can change the format, you can apply your data analysis. There are also some data tools that are available on the cloud server, just like how we see with Amazon Else and how we see with the Google Cloud and Microsoft Azure. They are available to you. Of course, some of them are paid services, but you might utilize the free part of that where you can practice on retrieving the data and see how beautiful this can be in your work. The data management include different components. So the way that you store the variables, this is how we call them the columns, and it go vertically. Also, the way how you store and look at the data, in a horizontal way. This can be called the observations. So when you look at a table, you have different rows and different columns, and each one of those cells, this is what you call them values. So when you collect data, let's say you are working on a survey or you're collecting patient data, you store this data with the patient name, the patient treatment, and then each of those rows, they are concerning one patient. This is the observation. And the column, those would be different patients. Each of those cells would be the value or the variable that you are collecting. If you look at the structure of the table and how it's stored in the database, usually there are some headings for the table. So the table has a title, sometimes they have a subtitle that indicate what this table or what the variables are indicating. Or it can give you some footnote where you can give the data source, how the data has been collected, what are the key icons or the key factors for the data. Sometimes you write some abbreviations so you can have more information and more description about each variable. You usually store the cells as labels. So you want to label each column and you want to label each row. And this tells you some information about what this data is. And then once you have all the table constructed, you want also to come up with what we call the data dictionary. And this is how you describe the data. During your work, you collected different data. You stored the data in different tables. So let's say that you have table A and you have table B, and each of these tables, they have different variables. Now, in your analysis, you want to retrieve a few rows from each of those tables. So you want to retrieve row 5 from table A, and you want to retrieve row 2 from table B. How you do this? This is how we do by the coding. So you can use an SQL code or you can write a Python or an R code to retrieve and select those rows. And you want to view the data that you collected from different tables. This is what we call a data framework. And a data framework, this looks through the server, it looks at the view and it collects the rows from different tables. For example, when you work with the Microsoft SQL, this is how the data is stored. It's stored as different views and different tables, and it's not like how you are seeing the table as an outcome. So all those variables are stored, and then when you write the code, it go to each table and it have some views. It create the framework for you. It create the table that you would like to analyze. If we take an example, if you are familiar with Microsoft Access and how you used to link each of those tables, we need to have a key indicator, like a primary key. Let's say that would be an ID that you give for each patient or each gene. Those ID are the link and the connection between the tables. You cannot connect tables if you don't have that key. So if you have table A and table A, they have different variables. We call those variables and we sort them as columns. So we have table A that has variable 1 to variable n. We have another table that's connected with the same key, which is the ID variable. And those also have different columns that are sorted as variable 1 to variable n. You have table C and so on. Now we want to retrieve one variable from table A and one variable from table B. The best way to do this is to create a query and you ask in that query, get me variable 1 from table A and get me variable 3 from table B. Then you want to put all those rows that you are retrieving into a new framework or a new data frame. It's called the table. And then this is your outcome table. This is how you write the code in any of those scripts. Now, the way that you can merge and join the data, it takes different views. If you only want the connection between the two tables, so this is what you called the inner joint. So you ask your query to only get those variables that are common between both tables. If you want all of what is included in table 1 with the intersection from table 2, this is what we call the left join, and you take this into consideration when you write your script. If you want the other side and you want to go from the right join, take all the data in table 2 with the intersection from table 1, you do the right join. If you want to retrieve everything from both table, and this is what we called the full join. Think of it like the mathematical logic and or logic. So let's take an example. For the inner joint, let's say that you have certain treatments and you have different patients. Some of those patients can be common. So the patient can take treatment A and treatment B, or the patient can only take one treatment. We can have two tables, table 1 with the first treatment, table 2 with the second treatment. And I have different patients. I have here three patients. One of those patients, they received both treatments, and the other two patients received only one treatment. Now, we have those data stored at different tables. So we have table A or table 1 and table B or table 2. Now, we want to retrieve only that patient that received both treatments because you want to see the interaction between the two treatments. So this is what we called the inner join. And here you see that patient number 2 is the one that received both treatments. So you will retrieve the value for the treatment 1 and the value for the treatment 2. And this is how you can look for different rows in the data. Now, if you are looking at different research question or you are putting a different hypothesis and you are only looking at patients who receive treatment 1, regardless if they receive treatment 2 or not, and you want to look at the efficiency of treatment 1. In this case, you are looking at the left outer joint, which means that you are looking at the patient who received the first treatment. You will see that the second treatment is missing for patient 1, but it's present in patient 2. And this doesn't really affect your analysis. Take this as the OR logic when you do the math. If you look at the other table and you want to look at those patients who only received treatment 2, regardless if they received treatment 1, think of it as the logic model OR, and this will include the patient that received treatment 2, and that would be missing for patient 3 that they did not receive the treatment 1. And this is how you want to join the two tables in your analysis. Now, if you want to look at all the tables, so this is what we called the full outer join. Think of it. So you have two tables, you have three patients. Patient 1 received one treatment, patient 2 received one treatment, and patient 2 also received the treatment 2. Patient 3 received treatment 2. If you want to collect all the information from both tables, so this is how you can do it's the and or. So they received both, or at least they received one. And this is how you look at all the data, and then you want to retrieve the data from your server. Next is now you have the data, you retrieved what you need for your analysis. The next step is to apply your analysis, come up with some inference and some insights. You see that the data can come as raw data. It doesn't have any meaning. And you want to transform this raw data, structure them, and then sort them in a way where you can analyze them so you can have insights. for what you want to prove as its evidence-based decision making. You can solve problem, you can find treatment, or you can effectively communicate your findings with other researchers. The data strategy process include different components. It starts from data collection and sourcing your data, where and how you will store the data, how you will manage it, how you will keep it safe, and you make sure that it's up to the quality and you are keeping the confidentiality, especially if you are working with some sensitive data, as well as what are the data tools and the analytic tools that you will use to analyze your data. So those are the different components. Now we look at the variables that you collected. So let's think about it. If you do a survey or if you apply a treatment, each of those components is called a variable. And a variable can be something that keeps changing. We have two types of variables. We have the variable that you keep changing, which is the independent variable, and you have the outcome that comes out of changing your variable, and this is what you call the dependent variable. You can sort your variables into different categories, and those categories will allow you different options for the analysis. Your journey with the data analysis, it starts from collecting the data. So you want to make sure that you have a problem statement, you set your hypothesis, and you have a clear and defined research question. Once you collect the data, make sure that you clean the data. There are no missing values or values that look not matching with what you have collected. Then you want to transform all those data. For example, you can code the data if it's like not numerical data, you can put some codes like zeros and ones. And then you want to reduce any kind of bias or any kind of getting data that doesn't have any sense or insight. Take out the outliers, take the data that doesn't make sense or some errors. Once you clean all the data, you want to store this data, and it's always recommended to make a backup. If you have sensitive data or data that you do not like to share, make sure that you have a password to access those data. After you collect the data, you cleaned it, you need to come up with a dictionary. So if you have colleagues, you can share this data. They will be able to understand what each variable meaning and how did you collect the data for it. The data dictionary, think about it as it's the key for reading your data. So if you abbreviate the variables, you want to come up with description for the variable. If your variables, they are numeric, they don't have any meaning for other people to read. So you can code them as zeros and ones, or you can give some numerical number where it indicates what does it mean. You want to list all of the variables and you want to give some description. Now we look at different data types. So you see that we have numerical data and we have non-numerical data. And this is where we come to quantitative and we come to qualitative data. The quantitative data, those are the numeric data, such as the numbers. The numbers can be continuous or could be discrete numbers. We have categorical data, and this is what you usually collect as words or different meanings, and that could be an ordiner, something that you can sort, or nominal, that's something that doesn't have any sorting, like colors, for example. Now, with the variables, when we talk about quantitative data, especially when we talk in research and physics and bioinformatics, we talk about different types of continuous and discrete numbers. And that could be something simple, something can be measured, like temperature. And when you talk about discrete variables, this could be like numbers that maybe are not related, but there are some kind of frequencies between them. Now, when we deal about qualitative data, that could be coded. And if you have to variables, this is where we call it a dichotomous variable, and it has only two options. For nominal variables, here you can have three or more of the options, and they don't have to be ordered. So there's no order like first, second, or last. And if it's with some order, so this is where you put it in ordinal classification, and that could be a ranking, for example. So take into consideration all those definitions when you sort your data, getting them ready for the analysis. Now, the next part is for how would you analyze the data? The data analysis depends on what is your objectives. Are you looking for some statistical components? Are you looking for diagnosis and you want to have some insight about treatment? Are you predicting a model? Are you looking at what would happen? Or it is a perspective and you want to see how things are going. At your work, when you deal with big data, and this is a massive rose, probably you are dealing with millions of records, there are two components. There are the component with the software that you are using, and there is the part where it comes with decisions and actions. If you deal with descriptive analysis, and this is where you are looking for some distribution and some trends. So you want to explain what happened. In diagnostic analysis, you are looking at why did this happen? Are there some risk factors? In the predictive analysis, you want to see what will happen. So now you have some informed data and you want to come up with decisions and take actions for future. In the perspective side, you want to see what should you do. And this is how you can come up with support in decisions and how you can come up with some automations. So take in mind what is your projective and what is the goal of your work. In the data analysis types, when you look for statistical analysis, usually you are looking at trends and patterns, and this is where you want to identify a measure, such as the central tendency, the mean, the mode, the median. For diagnostic data, you want to identify the root cause of a problem. When you deal with diseases, you want to see what are the positive and negative impacts, and you want to take some actions or you want to propose some treatment. For the predictive analysis, this is where you collect historical data. So you come up with some classification methods. You want to write a predictive code, and then you want to see what is the network between the different variables. This is like how you do with the KIG network for the genes. The perspective part of the analysis, you want to combine all those insights of the three levels of the analysis, and you want to come up with an action plan. And this is what is the next step. Now, for the statistical analysis, when you deal with some research question and hypothesis, you want to take this step into uh, different actionable measures. So you want to come up with descriptive analysis where you see the distribution, exploration of what is the data infer, if you can come up with predictive models and what would be the takeaway of this analysis. So in the descriptive part, you want to come up with a summary so you can understand your data. In the exploration part, this is where it involves some visualization and you want to look at the pattern. Where is the maximum? Where is the minimum? How does the outlier come up? In the inferential part, and this is where you want to draw a conclusion about the population that you are talking with, patients or certain variables that you have collected, and take into consideration about how you are testing the hypothesis. And this depends on what is the objective, and then here where you want to come with some statistical significance. Some of the data can be statistically significant and it has no biological plausibility, or it has some biological plausibility. So you have to take into consideration how your data will look like. The relation in the regression part is how you want to connect and relate those variables that you connect, especially when you talk about risk factors. You are talking about gene or about protein and how it relates to certain disease or it's affecting a person. The analysis roadmap starts with how would you define your research question? So you want to ask your question, what is the one research question that you can address in this study? Don't overwhelm your work with different research questions. Focus on one. What is the population or who will be your target so you can infer from this study? And what would be your predictor in outcome variables? And think about it as the X and Y variables. Now, for your search hypothesis, every experimental research has to come up with a research question and a hypothesis and how you set your connection between the variables. So you want to see the outcome, how it's different by from the predictor, the independent variable, and then how it's relate to it. So that will govern how you would analyze the data. So do you have one variable, do you have two variables, or you have more than two variables? This is what we call a univariate analysis, bivariate analysis, or multivariate analysis. Usually you can use a simple software like Excel, or you can use advanced tools like SPSS, SAS, or what you have available to you. In your data analysis, if you are working with just one variable, so you are looking at some descriptive analysis, you are looking for the distribution, the skewness, and what is the maximum minimum value, some sort of how you can explain the data. If you have two variables and you are looking for some sort of relationship and you want to see how it's a strong or weak relationship, that could be linear or could be some sort of a relationship that you would like to explain. If you have more than two variables, so you have different categories and you have collected different predictive. So you are looking at probably some bar charts where it can explain the different categories for you. Start your research with a hypothesis, and a hypothesis is you want to null the relationship that you would like to prove. So state a clear hypothesis, make sure that you connect the two variables, then you can conduct your experiment or you can do your analysis if it's theoretical. Now you want to choose the appropriate test of statistics so you can come up with some significant values in inference. Now you want to come up with the decision if it's significant and if it's plausible. Then draw the conclusion about what you have collected. For the statistical analysis, the simple way when you talk about two variables, so you have the independent and dependent variables. If your independent variable is of categorical uh, type. So you are probably looking at contingency tables. So that could be a simple chi-square test. If your independent variable is categorical, but your dependent variable is continuous, so here you might look at the difference between the group means, and that could be a t-test or one-way ANOVA test. If both of your variables are continuous variables, so here you are looking at correlation, and that could be the Pearson correlation. You can look at linear regression analysis. If the outcome is categorical, so you can look at logistic regression analysis, and here where you can look for interaction, like protein-protein interaction. There is a map, so you don't have to be puzzled, and this map you can find it on the website. It tells you which test to use when you are having different variables. So if you have continuous data, and if you are having different groups, let's say you have two groups, so probably you are looking at paired t-test, and you can select the best test statistics. You can apply this using the code if you are using R, or if you are using, for example, Excel, and then you can come up with your analysis. Now, the next part is how to visualize your data. You analyzed it, now you want to make it with some visual. The key for the 21st century in research is more about data visualization. You will see now everyone is paying a lot of attention for how you present your data. It's not just number, it's more like visuals. So there are a lot of open data sources, dashboards, and make use of the data sharing. There's a lot of data sharing agreements and how you can access open sources. Data visualization, it highlights the significance of the data that you collected and the data you are analyzing. It shows the reason for what you want to sell, and it shows you the spectrum. It explains the why, the what, the how, and all kind of those questions. There are different types, and it depends on what variables you have. You can represent your data as charts, as graphs. It can be a heat map if you want to see the treatment, the radiation treatment, and how the cell is absorbing the radioactive components. It could be some infographics and dashboard where you can explain and show people where we are from this variable. Data visualization tools, there are variable, wide range of them. If you are looking at data visualization like something simple, you can use Microsoft Excel, you can use Google Data Studio. There are good platforms like Tableau and Power BI. For some statistics, you can probably use R and Python. They are free. Probably SPSS and SAS, they come up with some membership and subscription. If you're looking at real-time data visualization, there are very good tools with Power BI. Power BI, you can export data from different platform and it show you real-time dashboard. So how do we do today? Think about it like the stock market. Infographic and presentation, you can use different tools, and Canva is one of the tools, and it's available for free if you want to use the simple features. For dashboards, Tableau and Power BI could be the best options. So data visualization come with some rules. So make sure that you are clear and you make things simple. So avoid putting everything in your visual data. Don't clutter your graph with a lot of information. Just make sure that you label the axis, the x-axis, the y-axis, put a title, and be accurate in presenting the data. And try to avoid anything that is not related to what you want to say in your graph. Make it simple and let it explain itself. Now that you analyzed your data, how would you communicate the results with your audience? Is it a sort of comparison between the variables? Are you showing the distribution and the trend? Are you looking at the composition of what you have collected, or you are linking and looking at the relationship? So take into consideration if the data is static or it's dynamic, it's changing over the time, and what is the purpose of what you are presenting. Is it for research and you are looking for some trends, or is it, for example, for training and you would like to show students how the data look like? Yes. This flow chart can be recommended as your cheat sheet. So, depending on what's the purpose that you are highlighting the results, you can choose what type of chart you can select. There are wide range of varieties. For example, do you have a static or do you have a dynamic data? Do you have like a real-time series analysis? Or are you showing some heat map? So you can select from the variety of options and you can use some tools to help and guide you in your selection. For example, for comparison analysis, you can simply select the bar charts. If it's a kind of a distribution, you can choose a histogram. And there are variety of visualization within each category. Now, the way you want to represent that trend depends on how you are using the lines. Is it increasing and decreasing values so you can show lines that going up and down? Are there some variability in values so you can show high and low and in between the bars? Is it fluctuating over time or it's steady? There is no change. So, depending on your observation, you can represent your chart. In summary, this table can be your guide for how would you like to highlight your results. For example, for distribution, you have options between the line and the column representation. It depends on what variables you collected and you want to tell your story. There are wide variety of good selections for the tools that you decide to use. For example, the most recommended and probably it's accessible would be Microsoft Excel. And now with Microsoft Excel, Python also have an add-ons for Excel. So if you know how to code in Python, you can combine and use Excel. For dashboard presentation, you can also use Power BI and Tableau. Python also have libraries where you can use like Plotly. Make sure and take into consideration the clarity of what you are presenting and make it simple, one message per a graph. In summary, for effective ways of visualizing the data, select the best and appropriate infographic. Conduct your message by simply reaching to your audience. If it's too technical, try to make it simple and remember to label your data and the axes. Let's have this example to work through and see what is the trend. For this table that you are provided with, you have two variables. You have a measure that's collected over the years. Now the question is, what's the message? What do you want to show? The first thing come in your mind would be this is a static, so the data is collected and it stopped. The best way to present this data would be by a bar chart. So you can present your x-axis with the years, the y-axis with the measure. Make sure to put your units and label your axes. Now for this chart, what is the trend? What do you observe? So you have some low values in between and the maximum value. So you want to highlight the difference between the minimum and the maximum. So you can say that over the years, there's a percent increase, for example. One thing to consider when you want to represent this to your audience is try to make it simple. So you might remove the redundancy in representing the numbers, as well as this is too colorful and it will distract the point that you would like to highlight. Make it simple, just use two colors, the one that is show the maximum, and everything else can just be with one color or you can dim it. This example is simply showing you data that are collected over the time. you see that there are years, and within the year, there are some rows, and there are some collection of data. And those data are categorized as category 1 to category 6, and you have different variables along the way. You want to see how these variables can be labeled. And then the next question will be, what's the takeaway message to represent such data? For this type of data, the best option of your selections would be the time series. So with the time series line chart, you can show different time brackets, and this is showing the years. Within each year, you can show the trend over the month. So this is showing you the minimum and the maximum change over certain period of time. This gives you the whole picture from the date you started your research to the end of your data collection. There is another way to show this using the line chart, and here you can represent it using markers, and the markers where you can show the value for each of those dot plots, as well as you can show the category. You can play around with the size of the marker, so you can make it larger if it's the maximum value. You can make it minimal if it's a small value. Let's take a look at this type of data representation. You collected data for different groups, and we highlighted the difference using different colors. Now you notice that two of the lines, the green and the light blue, they did not start from the beginning of the study. So can this data be representative of your collection and how you can tell the story? The answer for this question would be, of course, this is a reliable data. So when you started your data collection, there are two groups, which is group 1 with the green line and the group 3 with the light blue line. And those groups did not start when you started. So it's still reliable that you have to show the full picture, and you want to interpret this and explain it, justify it in your analysis. Next step is you collected the data, you analyzed it, you represented it in some visualization tools. Now, what is your story? What's the takeaway? And how you can put all those components and elements in your writing. Let's look back at the time of the pandemic when we wanted to collect a real-time data. That was a type of dynamic data. It was changing over each hour, over every day, and for the whole month. So we came up with ideas like creating dashboard, and the dashboard consists of different type of tables. If you can recall back how we retrieved the data and we worked with the different tables, so each of those data are representing different tables where there are some variables, and in your dashboard you select the type of the data to represent, you select the location, and then you select the type of the visual for telling your story. Another way of showing your data would be some dashboard for the data hubs, just like the genes and the structures of the protein that you retrieve. In the hub, you have the data tab where you can access and download the sequence of the genes or the SNPs, and you also have a static representation of the data. Those data are open and they have certain formats where there are some softwares that they read those formats. Also, there is a way where you can transfer this data from one format to another so it can be accessible to the software that you are utilizing. Another way of representing the data will be by showing your tables in different locations, and you want to highlight the story, just like how this data is showing an overview with what is the composition of the data that is selected, what are the risk factors, for example, and how you look at the time series and you look at the different parameters. In general, to design the story of showing your data, you want to start with an introduction where you set the stage about what is the background and the problem statement. You want to raise the action to present the data and the insight. Make sure that you make it important, highlight why you are presenting this and how it's important. The climax is how you want to highlight the key findings and the insights of your results. And at the end, you come up with the propose for the recommendations and the call for action. When you look at the art of the narrative, you start with the background and then you raise the bar high where you can use some supporting evidence, facts, provided with evidence from research, and then you want to come up with the main insight. What's your focus? What's the purpose? And then you want to go flow where it comes. This is what you did, and what is the next step and the recommendation. So the elements of effective data storytelling, it start with a clear message. You want to establish the context with relevance, support your point, develop a logical flow, and then use something relatable. It's always good to support with examples. The next level of how you want to connect the story is to use the right chart, the visuals, use good colors, some accessible colors, keep it simple, highlight what it matters the most, and don't forget to label your data. Let's take a quick quiz before we move to the next topic. So, in the data storytelling for biotechnology research, what's the order that you would work to best represent your findings? Would it be working with the data, the insights, the context, the call to action, or insights, call to action, data, then the context, or the context, the data, the insight, then the call to action, or the last option, which is call to action, data, the context, then the insight? So the correct answer would be the context, the background, then the data, the highlights and the insights, and the last piece is the call to action and the recommendation. With AI, we don't want to leave that part. So AI plays a great help, and that could be your partner in creativity in your work, whether you're working with data analysis, visualization, or storytelling. How can you let AI serve and help your journey? So there are different tools for AI, starting from ChatGPT, which is open AI and it's free. You can use some free features. You can use this for brainstorming. You can give it some prompts like, okay, these are my data, find me the best chart. You can also use Google Gemini, which is still free and accessible. You can look up some research. You can look up some codes. And Microsoft Copilot, it comes with the Office 365. You can use it, and it's very supportive for Microsoft Word, Excel, and PowerPoint, as well as Perplexity, which is also available, and it's an amazing tool with academic papers. There is Poe, and this is accessible over multiple AI models. Of course, there's Claude and there's others. I selected the top five that can be helpful. Now, some tips for using AI. So don't rely on AI as it can mislead you. It can give you false information. So use your critical mind and thinking. You want to have a clear prompt. So state the goal of what you are doing and exactly ask AI what is that you are presenting and what you want to highlight. So ask AI to suggest some chart for you. Of course, use your critical mind to see if AI is directing you to the right way or it's just messing up with you and it's taking you somewhere else. You can also share the data. Just remember, if there's any confidentiality with your data, you want to take it out. And don't share everything in AI because it's an open source, open access, and you want to keep your work private. You can ask a step by step, especially if you are working with codes. You can ask AI, okay, this is my problem. Create a Python code or create uh, or a script for me. How can I analyze this data? And use this as a guide. You can change with the variables, you can label it, you can rename it. At least it will give you the foundation of how you can start. You can also ask for examples. You can ask AI to show you some peer review articles. You can ask to show you code, sample of the codes, or you can see how this can be relevant to what you are working on. Always take, iterate, and improve. Don't take it as is and put it in the way that you would like to represent it. Now, this is a sample prompt for how you can use it for your strategy. So you can say, outline a simple plan for collecting, cleaning, and analyzing the survey data and mention the topic. It's always good to give information. So you play the role. Ask AI. You are a researcher. You're working in this topic. These are the variables. This is the data. You can upload their Excel sheet and ask AI to give you some strategy. You can ask AI to give you steps about how to start your research. For the analysis, you want to explain how to find the correlation between the variables. Explain it. You can also ask AI to give you the code for Python to perform the analysis. In the visualization part, you might ask AI to suggest the best three types and you select one. Look at the variables and make sense. Is it something that's representative with a line chart or with a scatter plot? And then for the storytelling, put your words and ask AI to organize it, summarize it, and highlight the findings for you. For the last piece is the interpretation. You might ask AI to explain what does this regression mean and how you can come up with some examples. See what other papers did or what other researchers communicated their message. Take the message and see what will be the call of action for the recommendation. So, with using AI, this is your assistant. It will accelerate the time. So, if you are taking, let's say, number of days, AI will give it to you in a few minutes. It will speed up the process for you. Take some insights and put it into visuals. That would save you the time and the effort. Now, for life sciences, it gives a hand on help for complex databases. We deal with big data, we deal with genes. Sometimes it takes you a lot of effort and time and resources to look at the connection. AI will connect and link all the online resources and provide it to you. You don't need to go to the library. Everything is provided to you with the cloud. So there are different benefits. It can identify the pattern. It can give you idea about the trends of the large data. It can automatically create some relevant charts and dashboards. And we are talking with the generative part of the language. So make use of the language model and try to come up with creative ideas, iterate and improve. For the visualization, it matters a lot because it turns the complex data into a clear visual. It gives you the insights. For our work in biophysics, bioinformatics, and biotechnology, the best tools to learn would be R, Python. There are so many libraries that are very helpful. Also, I would recommend Tableau and Power BI. They are an amazing tool for creating dashboards. Try to specialize the tool that you are working on, and it depends on what is available. I wouldn't recommend that you spend money and don't spend a lot of budget. If it's provided to you through your workplace, take it. If it's not, then it's recommended to search for the free ones over the internet. There's a lot of open sources. Now, for the storytelling, AI help you to pinpoint the significant correlation if you are not seeing that connection, or if you oversee that, it will take out the outliers. It will pinpoint to the picture and what is the outcome. So with the generative models, you can recommend the story. You can simply have technical language that can be for diverse audience, and the visual, it will help you in selecting different charts, and it will summarize the results for you, both for your technical audience and for the public audience if it's a general presentation. So, a quick quiz. Which principle is most important to avoid misleading visualization? That would be maximizing the decoration of the engagement, or using many colors, maintaining the proportional and the accurate scaling, or exaggerating the trends for the emphasis. Sometimes you want to highlight it and you want just to exaggerate. So, which of those would be the correct answer to avoid misleading the visualization? So the correct answer would be maintaining the proportional and the accurate scaling for your data visualization. Another quiz: in the storytelling with biophysics data, which climax, which is the content of the narrative that you usually focus on? Is it the technical part with the detail of the data collection? Is it the introduction of the research question? Or are those the key findings and the insights obtained from the analysis? Or is it the background information about the researchers? And the correct answer will definitely be the key findings and the insights that you obtained from your analysis. For molecular biophysics, you are visualizing your 3D protein structure. So that's often require which type of those tools? Would you use Python scripts with the matplot, or would you use Microsoft Word, or some tools like Pymol or Chimera? Would you use a spreadsheet and macros? And the common tool would be the Pymol and Chimera. Today, we cover different aspects for the strategy of data collection, analysis, and visualization. We looked over different types of data and sources and some of the tools. The takeaway of this presentation: remember, make sure to define your problem. What is the interest of your research? Set your goals and objectives. Design the method from the start of your data collection, designing the variables, coming up with the data dictionary, and then up to the results where you can come up with the insights and the visualization to tell the story of your work. Best practices: make sure to align the data strategy that you designed with the research goals and the objectives. Keep the visualization simple and focused. Craft a compelling narrative around the data. Make it sound important and highlight your message. Test and iterate and always look for improvement. To wrap up what we discussed, data strategy has elements that you want to keep in mind in your journey. It starts from the management of the data, collecting the data, designing your surveys, or doing the tables, the type of the analysis, what's the purpose of your analysis, how would you ensure the quality of the data so it will be reliable for others to rely on and to repeat, and what's the takeaway message and the recommendation for future research. The takeaway: make sure to integrate different framework of data strategy, different types of visualization, the narrative for your story, and make it impactful for communicating with other stakeholders. And keep in mind to build and keep building on your skills. Every day there are new tools and there are developments. So make sure that you read a lot, take courses, learn tools. They're open sources. You don't need to worry about budget. Some of those are courses that you can attend online. There are some tools that you can learn from the companies themselves, like Office. They do provide some helpful sites. Some of the tools that will be helpful for you would be learning Excel, that's number one. Python and R would come if you like coding. SQL, it's an amazing tool for managing your data. And if it's your workplace, they recommend it. There are other dashboards that you can learn, like Power BI and Tableau. Some fun reading, and this is not too technical, would be the charts, how to learn how to say your story with chart. There's also some other reading about data visualization, and there is a nice AI book that's by one of the Egyptian innovators in AI, and she used AI for social recognition and facial recognition. That might be an interest for you. And at the end, I would like to thank you. Please feel free to email me your questions or reach out if you need any resources. Thank you and enjoy the rest of your day.